Now the next thing is range. Well, we know that range is our y values. Domain is the x values, range is the y values. Okay? The best thing to do to find out which y values work is to graph the function and look on the calculator. Okay? For example, let's graph this function. F of x equals the square root of x plus 4. We already know from over here that the domain is from -4 to infinity. So what is the range? Like I said, what I would do in this case, okay, is I would get out my calculator, turn it on, turn this on here a second, and
It's a scatter plot.
yep, well, we're going to turn it on and we're going to go the square root of x plus 4. Okay. And we would take a look at it. And when you take a look at this function right here, like I said, the x values that work are from right here, from -4 to infinity. If this keeps going, this is going to keep on going up. The range is the y values along the y-axis. Does this graph go below the x-axis at all? No. Okay. Does it touch the x-axis? Yep. And if I kind of go to my table and I find out, yep, right there, I've got that, okay? Yep, that's from -4 on down, but you see that it does equal this. All right, so our range then is from 0 to infinity. Because this graph, although it's going to climb really, really slow, it will eventually keep going up and hit all the y values.
Is there any way you can plug infinity into your calculator?
You can plug into, no, you can plug a very large number in for x, but not infinity, obviously. And your calculator is a small computer. It can only handle such a large number, and then it might say overflow. So, and I have never experimented as to how high you can go. Okay? All right. So range is best found on your calculator. Okay? All right. Oops, sorry. That's right. Okay. All right, the next one is called continuity. In art class, did you ever draw a picture by putting your pencil down and then try to do one continuous line to draw the whole picture?
Oh, Mrs. Arvo.
Okay, well that's called, a function is continuous if there are no breaks or jumps. So continuity means there are no skips, gaps, or holes in the function. In the graph of the function, how about that? Okay? There are different types of continuity. Okay, I'm going to draw like a little diagram, and that might help you out a little bit. Okay? All right, let's start with functions. Okay, functions are separated into two different categories. We have continuous, okay, at all x. And a function is continuous at the point. So it would look like, it would be a graph that kind of maybe went down like this, it came up, it swirled around, and then it ended up maybe, I don't know, going like that. There are no gaps, there's no jumps, it's just continuous, it keeps on going. Okay? And then we have something, then we have what's called discontinuous ones. Okay? Where there might be something. Now, discontinuous graphs are divided into two types of discontinuous graphs. We have what's called removable discontinuity. And, oh, lucky us, non-removable discontinuity. Okay, I'm just abbreviating. And I spelled removable wrong. There's no EA. Okay? A removable discontinuity is when you have a hole in a graph. And that's going to be if I have this function that goes like this, and it has like a hole right about here.
Why would you do that?
I'm going to show you an example of something that has a hole, okay? And maybe it's filled in up there. It's got a dot up there. Or maybe there's not a dot up there. But when you have an entire graph, but there's just one spot that has a hole, that's called a removable discontinuity. It's almost like you can plug it up then. Okay? Non-removable discontinuities are separated into two types again.
Of course there.
Of course they are. We have what's called a jump discontinuity.
Come on, run out of room.
Oh, I'm sorry. And an infinite discontinuity. Have you ever heard of a piecewise function?
No. I bet you're gonna write it down.
Well, maybe I'll just draw you a picture, then you'll see. A piecewise function looks like this. Part of the graph comes in like this, and then the other part starts here and goes off. It breaks up. Say that again?
What is that little black dot in the
Here? Oh, what that means is that this curve is right here, but its value is right up there.
Oh.
Okay? This is called a jump discontinuity. There's a gap. Okay? You're going to have a gap in your graph. You can't just fill it with one value and make that connected, okay? Infinite discontinuities are when you have asymptotes. That'll be something like you have a graph that kind of comes like this, and then maybe you have another one that comes in like that, and you've got this asymptote here. Okay? They're called non-removable because you can't put just one value in there to make it continuous. At this one, you can just put one value in, close it up, and it works. I'm going to give you an example of something that's a whole or a removable discontinuity. An example would be if I had x squared plus x minus 2. Okay? And then in my denominator, I have x plus 2. Okay?
First, is it you?
Yes, it is. I'm trying to turn it down. How do I turn this stupid thing off? All right, just ignore it, okay? Somebody's sending me a message. Just ignore it. All right, so if you factor the numerator, like that, you're going to get x plus 2 if you look at this, what value makes the denominator 0?
-2.
Okay, so at x equals -2, I'm going to have a hole because this and this go away. If you graph this function right here, and I'm going to graph it on my calculator, okay? If I graph that function, and I type in, here we go, x squared plus x minus 2. And then down below we have x plus 2. And I graph this function. It looks like a straight line, does it not?
It looks pretty dang straight to me.
It does look like a straight line. It looks like this right there, which is x minus 1. But if I go to my table, what happens at x equals negative 2?
Error.
That's because that's where the hole is. Now, because the calculator has these pixels, you can't see it. If you went to mode and you saw, I'm in dot mode right now, okay? So if I take my window and I make my window smaller, oh my gosh, like that, you can barely see
It looks
at negative 2. There should be a little gap there, but I don't see it, so
Zoom in closer.
I don't know if I could.
Hey.
All right, if I need to get right there, so I don't need that and I don't need that. All right, we will try one more time. Let's zoom in, and let's zoom in right about there.
Oh, I never knew how to use that zoom
I don't see it, Mrs. Ritchie. I think you're making it up.
I'm not making it up. Mode. There's connected.
I see it right now.
No, it wouldn't be in connected, it'd be in dot.
I don't see it. You're lying.
All right, I did it last night and there's a gap, but we're not going to worry about it right now. You can see it, but know that that's where there's a hole at x equals negative 2. Okay? All right. All right, the next thing, after continuity, check that off, is we need to talk about where a function increases and decreases. Okay? Functions increase. Okay, they increase and decrease over x values. Okay? For example, okay, take a look at this particular function right here. Okay, you start at the left. Start right here, okay? And you act as though you are climbing up the hill. Yep.